So we want to do a conservation of momentum problem. Here's your problem. You have two objects. One of them happens to be at rest, mass is 2 kilograms, being hit by a 1 kilogram mass traveling at 2 meters per second. The collision happens, and then after the collision, one of the objects travels at 0.5 meters per second. We want to find the velocity of the second object. In terms of a setup here, we're going to use our conservation of momentum law, and we're going to let the momentum before equal the momentum afterwards. In terms of setups here, we have two objects, so we're going to have two terms on the right, and we're going to have two terms on the left. These are the initial conditions. These over here will be the final conditions. We're going to indicate that they're final conditions with a little prime above the V. Again, that represents a final condition. In terms of making the problem a little bit easy on ourselves, we'll notice here that this object's not moving, so we're going to take this term right here and cancel it out since the velocity is 0. In terms of plugging, we have the masses, we have the final velocity of one, we have the initial velocity of the other. Solving for V is just a matter of plugging and chugging at this point. In terms of setups, while this is a common delivery, there is another common delivery that happens. These objects collide now, and instead of traveling off by themselves, they become connected, coupled. Right? These two objects now are connected and travel off at one final velocity, and we want to find what that final velocity is. The change in the problem is that when we take a look at the right side, since they are connected, we no longer need to decipher between 1 and 2. It's just one combined velocity. If they both have V prime in them, I'm going to go ahead and factor out the V prime. I'm going to go ahead and write this out and with the masses together. The left side's still going to have that one object moving with some momentum. To finish up this problem, we're probably going to be solving for the final velocity. So let's go ahead and just clean it up a little bit. I'm going to combine those masses and make it one term, mass total, times one combined velocity V prime. And if I'm solving for the final velocity, this is just a matter of taking the initial momentum of the object, dividing by the new total mass, plugging and chugging once again. That's a special type of collision. We'll call that a perfectly inelastic collision, where the objects collide and become connected. Previously, it could be an elastic or inelastic collision. It really depends on energy before and afterwards, but that's for another discussion.